So in terms of configuration template, I'm sure you must have gone through the configuration template, what it does, what sort of setting we need to have. Like, it's not necessary to have one template to attach 100 devices or 100 template attaching to 100 devices, right? So you have to plan those things very sensitive way and define it what can be a common pointer. Let's say system. System is something you can have a common template for every device. The system going to have host name. You're going to have the GPS setting and a couple of things, right? So there are a couple of parameters that you can set it. As of today, if you set up the default setting, default means it's not going to change anything. It's going to be as it is, what is your device. And second is like you have device specific. That is where you can set up a couple of parameters like system and all. You can set device specific, and for those devices, you can go and set a value for it, right? So ultimately, in that case, you are able to use just one template for 100 devices, but not everything, but it's just a couple of parameters of it, right? Because when you use at everywhere, then you're going to have difficulties, let's say, if you have some different sort of requirement to do that, right? So there are a couple of values, like you can have a default setting, which means no changes are going to happen for that particular parameter, considering these. If you want to have device specific, which means when you attach the template to the devices, you're going to have to fill those parameters, which can be to the device specific, which can go to every device is going to have unique parameters, right? When you say global, global means you're going to put the value, and that value is going to be to be common to everybody, and that is what we have as of today. Do we have any question in this? Because template is like we have a lot of things when we attach to the devices. As I said, you can have one template to 100 devices, and sometimes you can have 100 template to 100 devices, but you have to plan your templates very sensitive way so that you should leverage a template to cover most of the devices. Let's say you can divide based on the data center category, you can have branch category, you can have regional category, and define the templates accordingly. This is how it looks like. So when you go to the template, you can see here this feature template has been called 16 times. How many devices it is attached? What is the device model? It's not necessary to have this template just for one device. You can change the device model. You can have this template for some other device. Let's say you can have ISR here. You can have ASR. You can have your VH1000. You can just put those device models, and this template can be applied to those. It's not necessary to have a template for one device model, and then you can create another template for another device model. So you have an option to use the same template for multiple device models. Could be ISR, ASR, VH1000, VH2000, anything you would like to. So ultimately, you have option to leverage those options. Oh, sorry. This is very important tool. We have recently introduced this. If you are having XC router, let's say ISR 4K ASR 1000, right? How you convert your configuration from legacy to SD-WAN? Today, what you do when I say today, means before this tool, what you do is like you have running configuration, then you plan what is going in transport side and how should I convert that transport side configuration to Viptela to SD-WAN world, right? To do that, you have to do manual stuff. You go one by one and then figure out what is supported, what is not supported, which command. And sometimes it's very difficult to figure out this command, what could be the meaning of this command in SD-WAN world, and how should I put this command into SD-WAN world. It's going to create a lot of headache. So we came up with a tool which can help you to create your configuration from legacy to SD-WAN. As of now, this tool is not open for everybody. It's only open internally, but it's going to come up a launch very soon in a few weeks, which will be available for each of you. You can leverage that tool. All you have to do is yeah. Yeah.
So if a Cisco router ships without the vManage enabled software on it, would it register to a DNAC controller, and then DNAC would upgrade the iOS, and then it would register to the vBond plug-and-play setup? Like, what's the scenario when it comes from manufacturing? It doesn't have Viptela code on it.
Yes. So there are two things. One is like going forward, we're gonna ship it a Cisco router with Viptela code. But what today we have is like you have to convert your XC SD-WAN router manually, or there is a bootstrap a step you can follow that, via which you can have your configuration preloaded and do the bootstrap way to upgrade the device. Device will upgrade and go and talk to the PNP. That's one way, but that bootstrap, it technically becomes one touch. It's not true zero touch. So, yeah.
Right. I was just thinking through like workflow on switches that have software and it redirects to a registered DNAC controller, right? Like, would DNAC be able to run that bootstrap script?
Yeah. So the point is like if the router gonna ship with the SD-WAN image, it's gonna happen as you mentioned. But until then, we have to follow a little manual step. So because you have to point out some way to the PNP server. So today you have to upgrade the device and do that. So the best way I would say, let's say you have a device, your templates has been configured, right? And the template is attached. So what you do is just upgrade the device, connect your DHCP port, and let device talk to your controller. So the moment you upgrade the code from XC to SD-WAN, it will go and talk to the PNP and figure out. So that's going to happen. It's just one step, which is upgrade. Apart from that, is everything plug and play. Thanks for the question. So about this tool, what you have to do is today, take out the configuration from your XC device, have the configuration to this tool. It will convert the configuration in SD-WAN way, and it will tell you what command, what models is not supported, and it will list out in the red color and tell you to remove that part. Once you remove that part and there are no exception, it will go ahead and create a template to you. That template will pushed out to your vManage, and you can attach the template to a device you want to. So ultimately, we are taking out all those manual work, you had to do, and we convert in quite automatic way. Just go ahead and paste it and get the configuration, what vManage does it, what it doesn't do, and we can come up with later on those supported parts, right? But you don't need to worry about it. Just going to figure out what is LAN, what is the WAN, what is IP, what should be the tunnel, what should be the service. Everything is going to be figured out by this tool and should be done. It's going to be launched very soon as the public. So do we have any questions on that? Yeah. The only thing you have to keep in mind, your vManage should be reachable from that tool. Because it has to be reachable. You're going to do a couple of API call to do and implement that particular template to the vManage, right? So the policy framework. So we have to understand the policy framework, which is very important. So far what we have discussed is like, we discussed about what is Cisco SD-WAN, and what sort of configuration, what sort of template we use to bring up those parts and the components, right? Now we are going to talk about the policy. The policy is very important here, the data plane, right? So if you look at the policy framework, what sort of policies we have control policies, we have data policies, we have app route, and you have local policies, right? So the policies which are centralized are getting pushed from the vSmart controller to all the way to the VH device. And the local policies are going to stay in the box where you're going to have defined local policies and call into one of your templates to have those policies. Centralized policies can be for one site or can be for multiple sites. Localized policy is local to you, and that's going to be applicable to you only. So once we bring up the devices from the PNP and have template configured, the next step is like the device is going to download your policies from the controllers. It could be a data policy. It could be the app route policy. In terms of control policy, it is not going to download because in control policy, we can filter the OMP routes or we can filter sort of hub and spoke scenario, but not more than that. So because that's mainly a traffic engineering scenario, right? So do we have any questions on that? Good. So the topology thing. So if you are aware about that, when we bring up our devices, it is by default full mesh, which does ECMP, right? So let's say you have quite big networks. So you have to plan those, how to customize, how to divide regional-wise your devices, because all of the devices are not going to support the number of branches you have. It's not going to support our scale that way. So you have to plan the scalability. You have to plan how you're going to post your or keep your branches and hub site, and how you're going to connect your branches with each others. So you have to plan those very wisely and figure out how to build out the tunnel, because it's not like all the devices are supporting 5,000 tunnels, 6,000 tunnels, right? So you have to plan those parts and bring out, let's say, go with a custom control, go with a regional solution if you have number of branches more than expected. So there are a couple of solutions for that. You can go with a centralized hub, where centralized hubs should be capable to support more channels, should be scalable, and then at the branch level you can have the devices, let's say it supports like 100 tunnels or 200 tunnels, and use that. So you don't need to use the high capacity devices everywhere just to support the number of tunnels what you need. Since we do full mesh connectivity between all the devices and bring up as a fast. And there are a couple of scenarios we can do it. Let's say you can have regional way, as I mentioned, but there are a few needs. Let's say voice traffic. It has to go directly. You don't want to go via a hub, because there are considering delay, jitter loss. It's not simple. So we can have a regional solution, regional policies, but per VPN. Let's say my data connection and everything, I want to keep it regional. I don't want to have those things talk to each other directly, considering my need and looking at my number of sites. But for voice, I can have full mesh. I can say, okay, voice can directly talk to each other, but not other VPNs. So there are a couple of things we can plan. As I mentioned, the scale is very important. We can't have those high-end routers every place, so we have to plan and have those sort of routers which can support tunnels between the region based on the need, and then you can have the hub routers as high capacity to build out the regional connectivity and go ahead from there. So these are the high availability scenario we do have available. If you look at what we have, the service side you can have multiple things. Service side, you can run VRRP as a layer 2 if you have layer 2 switch connecting to the LAN. If you have layer 3 options, you can run OSPF, advanced OSPF, redistribution sort of thing, and BGP protocol. At the WAN side, we have feature called the TLO extension, where you can extend your link from a router to another and another to the same router. So you can ultimately leverage your two links. If you have you have just one endpoint from the service provider. It's not necessary to have multiple endpoints from this provider, because it's not feasible every time. But if in case you can directly connect those links to the router. So ultimately, if you are getting two handoff from a provider, you can communicate a link to each. If you're not getting that, you can have extension, what we have today, extend a link from a router to another and leverage that. So ultimately, that way, you're going to leverage both the router as a box level of redundancy as well as a link level of redundancy, right? Having the feature like TLO extension. So do we have any questions? Because if you look at the TLO extension, it's a very often used solution, and there are multiple use cases we have gone through. So if you have any questions. So the important topic where we are, which we are here, is migration. How we migrate your site from XE to SD-WAN, right? That is what we're going to discuss about. So this is your current setup. So your routers are connecting to the layer 3 switch, MPLS is connected, and you have perimeter firewall. Everything is connected, running well. Now, when you plan your migration from XE to SD-WAN, we can't just take out from the day one everything, right? We have to plan. We have to make sure the services should not be interrupted. Services should be running fine. And at the same time, we have to migrate my branch, my data center or my services to SD-WAN as well. So what we do is, like, we start from the data center. We start migrating parallelly and make sure the services should not be interrupted, right? So there are a couple of ways we can do it. What we can do is we can have a device converted from XE to SD-WAN and connect the device via one of the link of internet, as well as your link from the C router, which is your MPLS. To make sure your services, which are already running, should not be impacted, should be the same, but at the same time, you should be able to leverage your SD-WAN case, right? So if you pay attention here, so I'm going to call a couple of terms. One is the transport side, another is service side. When I'm going to say transport side, that's where your WAN link is going to come, right? your WAN services, your WAN transport is going to terminate at the transport side, and the service side is nothing but LAN. So which means the LAN side, the layer 3 switch or layer 2 switch is going to connect to the LAN side, which I'm going to term as the service side, right? So the transport side, which is the WAN, I'm going to consider the C router, which has MPLS, because I want to interrupt my network, which is already running. And then I'm going to have another link to the firewall, which is my internet transport, to make sure I should be able to connect to my controllers if they are hosted in the cloud, right? After which, I'm going to connect one of the legs from the service side. When I say service, again, from the SD-WAN service, which is in the LAN side, to the device, which is my data center core. After having this connectivity, I should be able to go and talk to the controllers via internet, as well as via MPLS if I'm netting somewhere. If my controllers are hosted in the cloud. If they're hosted in on-prem, I have multiple ways to communicate about, right? So that's how the connectivity is going to be. So as I mentioned, I have my transports are connected through MPLS and internet. When I say MPLS, I'm considering your C router as a P for me. When I say me, it's like a branch as a SD-WAN, which is going to be migrated as of now. After which, if you look at how the prefix is going to come, is like they're going to build out control plane and then data plane on top of that, which is my overlay I'm going to call. So there are a couple of terms like overlay. When I say overlay, it's like what I'm learning from SD-WAN. So if you look at the flow here, so all the prefixes, right, from the SD-WAN side are going to come to all the way to the C router, and they're going to follow the green link to the VH router, to the WAN edge router, and give the prefixes back to the layer 3 switch. All the prefixes which are coming from non-SD-WAN side, they are coming all the way to C router, they are coming to the layer 3 switch, and then layer 3 switch is passing to the SD-WAN. So it's like the graph start from here, getting SD-WAN prefixes from all the way to MPLS and internet, all the way to the switch, and non-SD-WAN prefixes from the MPLS underlaid directly to the switch. So on this side, data center side, you're going to have both the options, both the routes available. You're going to go to SD-WAN, go via this WAN edge router. You're going to go to the traditional sites, you can directly go to the via C router, right? As well as if there are any sites which are migrated on the at branch level, they're going to come to this data center all the way to WAN edge router. They reach out to the switch, and they're going to get the prefixes where and how to go, and then they follow the C router. Do we have any questions on this? The connection? Yeah.
Do you generally recommend putting the WAN edge devices behind a firewall or directly terminating an internet circuit into the V edge or C edge?
So it's your data center. You're going to have firewall at any case. But we do not, I mean, it's not needed. As long as you're fine, we have.
Well, right. It may be an option. You could run it through the firewall.
Yeah.
And then if you're using that circuit for both, user-bound internet traffic as well as SD-WAN establishment, you can do your kind of shaping from a QoS perspective at one choke point on the firewall.
Yeah.
But you also could put the WAN edge directly connected to the internet circuit and not have a firewall for all
it's not necessary. It's not necessary. Yeah. The reason I said, because we're talking about the data center design. Data center design, you're going to have the firewall. So as you said, it's not necessary. It's not important to have firewall on top of the VH devices. You can directly terminate a link to the VH device. There's no issue. Yeah. We have things to take care of, those control plane track and all those things. Yeah. So at branch level, it's going to be simple because the branches have the way, are going to get the way from data center to reach out to non-SD-WAN branches. So there are a couple of things we can point it out when we leak the routes from SD-WAN to non-SD-WAN or non-SD-WAN to SD-WAN. Let's say you have this small branches, you can have one data center or one regional site where we can leak those routes. Or if you are a large enterprise, you can have multiple ways. You can have transition hub where you can leak the routes of SD-WAN to non-SD-WAN, and then have the branches going through that, or regional branches going through that based on your route filtering, what you're going to apply on those routers. And that is how we can achieve that part. And that way, you don't need to do underlay overlay route leaking. When I say underlay overlay route leaking is SD-WAN and non-SD-WAN. So you don't need to do it at a branch level or every branch level. All you can do is go at data center, or if it is a large enterprise or something, you are in, across the globe, you can have your regional exit. Let's say APJC should exit from APJC hub for non-SD-WAN prefixes, and EMEA should exit from EMEA hub for non-SD-WAN prefixes, and US should exit from US hub for non-SD-WAN prefixes. Similarly for SD-WAN. So if you look at the branch migration, you can take the router which is already running iOS XE, XE code. You can just have the SD-WAN code install and replace and convert that router to the SD-WAN. So I'm sure all of you are aware about how we did convert and how we are converting the XE router to SD-WAN. It is very simple process. Have your SD-WAN image on the router and make sure you check the memory requirement and then convert that that image, that particular router, which means just a simple upgrade from XE to SD-WAN, and the router will be SD-WAN. And then, as we discussed, once we have your ports connected and DHCP is going to do plug and play PNP and get it connected to the plug and play server and get the configuration pushed out from it. All right. So that's how it's going to be. Do we have any questions on, especially when how we convert on XE to SD-WAN? No? So the point is here, if you look at the differentiator pointer from the data center to the branch is this one. At the data center level, you're going to have underlay overlay route reachability via SD-WAN and via non-SD-WAN. But if you look at here, the branch level, because your data center is already built out on SD-WAN, now from the branch, you're going to build out your tunnels from the via MPLS transport or internet transport, and you're going to have both the routes available, because you can get those SD-WAN routes directly to the other branches which are running on SD-WAN and the data center, as well as non-SD-WAN prefixes from the data center. So the branch migration is very easy. You don't need to have underlay overlay route leaking every places or every branches, but you can have at hub level or one of the regional data center. So similarly, if you have two XE-WAN, SD-WAN routers running at the branch level, you can convert them together. There is no need of going one by one and have them running on SD-WAN, and then plug and play and leverage both the transport and run the protocol like VRRP or OSPF. You're free to run. If you have layer 2 switch at the branch level, you can run VRRP and use TLO extension to have both the links uses. And if you're running OSPF or BGP, you can run active, and ultimately leverage both the routers and both the links. All right. So if you look at the flow level, all the local prefixes will be injected to the OMP via redistribution, as well as all the OMP. When I say OMP, is like protocol what we are running from the controller to the VH device to learn the route of a site to another. So that is how we're gonna get it. Like we inject local routes to the OMP and learn the OMP route, which means SD-WAN site routes and non-SD-WAN site routes from the data center to the branch via OMP. So there are scenarios when you have MSP managing the router itself, right? So in that case also there is the option you can leverage SD-WAN. You can have the router connected behind the MSP managed router, which is C router, and take one of the legs and connect to that, as well as you can have a leg from internet and connect that to the SD-WAN router, and have your code upgraded if it is XE ISR, and keep the running your BFD sessions, build out these tunnels to the SD-WAN site and learn the prefixes. As well as you look at the workflow level, it's going to be the same. You're going to put your local prefixes to the OMP via redistribution, and then OMP prefixes are going to come to you via OMP redistribution to the local protocol. That's how you're going to have the communication from a branch to the data center or to another site which are on SD-WAN. Right. Do we have any questions, especially on the MSP level of migration when we have MSP managed router at branch? How are we going to have SD-WAN running there? Right. So this is how the flow is going to look like. Yeah. So So this use case is quite common as of today. So let's say you have a router running as a WAS, right? And at the same time, you would like to leverage SD-WAN. Now, if you look at, we are coming up with the same box solution where you're going to have WAS and everything running in the same box, like feature like call that app QoE. But as of today, it's going to be two box solution, right? So let's say left side router is my router, which is WAS, and the right side router is my SD-WAN router, right? What we did is we have got it 2 VRF on the router, which is running left side, which is a WAS. Technically, we put the transport side in a different VRF, let's say VRF1, and service side in VRF B.